All right, here's our video today on Ceres. We'll do a short video on Ceres, the former fifth planet. And that's true. It used to be called a planet way back in the 19th century. So we'll do a little short video on it, a little more information on Ceres. As you can see from the picture, it has this beautiful blue, and right in that crater over there has a nice white, shiny substance, which was a mystery for a long time till they finally found out that it's salt. But anyway, getting back to the planet. Let me get my little pen going over here. So a guy named Piazzi in 1801, an Italian astronomer, discovered it. It was round and it looked like a planet, and so he called it a planet. And it was a planet until about 1850, when they realized that Ceres was in the asteroid belt with a bunch of other asteroids. So logic dictated that in 1850 they called it an asteroid. But it doesn't look like an asteroid. In fact, Ceres is an oddball. It shouldn't even be there. We'll talk about that in a minute anyway. But in 2015, they called it a dwarf planet. Doesn't look like an asteroid. It acts more like a comet. And so it is a dwarf planet today. It is the smallest dwarf planet and the closest dwarf planet. And something that's special about Ceres is that it has a subsurface ocean, has liquid ocean, and possible ice volcanoes. So it's a very interesting, former planet or dwarf planet, whatever you want to say. Ceres was named after the Roman goddess of the corn or the harvest. So every time you have your cornflakes or your cereal, think of Ceres because that's where we get the name from. So this white stuff here, the shiny white stuff in this crater is not snow, right? It's salt. And it's not the salt, that table salt like NaCl. No, it's not sodium chloride. So not that. It's sodium carbonate. So you need sodium because sodium is put the U in there. There we go. Sodium is an alkali and it is what you need to make salts, right? Sodium carbonate. And I'll give you the symbol here. So it's sodium. You need 2 molecules of sodium. You need carbon and 3 molecules of oxygen. So that stuff right here, change the pen a little bit. This shiny stuff is sodium carbonate. And how to get there? Well, you can see that this is in a crater. So this big impact crater probably pushed up that sodium carbonate from its subsurface ocean and it froze again. And this blue stuff all over the planet, that blue stuff is minerals. And I'll give you what it is. They're called phyllosilicates. Let me spell that for you. Phyllosilicate. Let's change it to yellow again. Put it over here. See if I can finish this. There we go. Phyllosilicates are just minerals. They're silicates, phyllosilicates. And they give this nice rich blue on the surface. And the reason it's that way is just like why our sky is blue. Blue wavelength on the electromagnetic spectrum scatters faster than any other visible light. Remember, visible light. There's other types of light, like radio and micro infrared, X-ray, ultraviolet light, and gamma. They're all part of the spectrum. But the ones we see, the visible light spectrum, red is the longest and blue is the second shortest. Actually, violet is the shortest, but we see blue better than violet, and blue scatters better. So that's why these phyllosilicates, we're seeing blue all over the surface of Ceres. And by the way, going back to sodium carbonate, we can find it in the hydrothermal vents deep in the oceans of Earth. And the first, by the way, another fun fact about Ceres is that it's the first dwarf planet to get a spaceship that came to it. The Dawn Space Orbiter took pictures of it in 2015. And that's where we got these nice pictures that we're seeing. And I also said that Ceres shouldn't be there in the asteroid belt because it's in the asteroid belt with asteroids that do not look anything like Ceres, don't have any of the composition of Ceres. And so there's this theory that billions of years ago, Ceres used to be perhaps in the Kuiper Belt, or even closer, maybe perhaps past Saturn or Uranus. And somehow Jupiter or some of those gaseous planets kicked it into the asteroid belt. Because Ceres is in the asteroid belt, doesn't look like an asteroid, it acts more like a comet. Has water, has ammonia, and these phyllosilicates. All right, and here's the asteroid belt. I'm sure we're very familiar with it. We have Mars over here, and Ceres would be over there somewhere. And of course, there's Jupiter. So Ceres is, again, the smallest dwarf planet, an oddball in the sense that it shouldn't be in the asteroid belt. It's not an asteroid. And here's a better picture if you can look at all that blue, these phyllosilicates on the surface. And here's a comparison between the moon, Earth, and our Ceres, right? There's Ceres right there, in case you were wondering. Much, much smaller than the moon. So maybe one day they'll change it to a comet. It doesn't, because remember, like comets, it has a very thin atmosphere. Some scientists think it has no atmosphere, but it has a very thin atmosphere, and it has ammonia, which is very common in comets. And again, it has subsurface ocean. So just remember, Ceres is a dwarf planet that was once a planet, once the fifth planet in the 19th century, that has a subsurface ocean, is in the asteroid belt, but acts like a comet. And if we have any planned missions to Ceres, it'd be much easier to get to Ceres than it would be to Europa, which is another moon. It's a moon, that is, that has a subsurface ocean, a moon of Jupiter. It's much, much easier to get to Ceres. It could take anywhere between 18 months to get to Ceres, or to get into Europa could take 5 years or more. Well, that's just a simple video on Ceres.